Hello learners, welcome to Education Online program. I am teacher Willa Lucia. Today we are going to learn about something very interesting, which is known as the surface tension. What is this surface tension? If we're talking about the surface tension, we're talking about how the surface of a liquid behaves. So you find out that with surface tension, it makes the surface of a liquid behave in an elastic manner. You might think that there is some elastic membrane right on top of the liquid surface. So we can define our surface tension as the tendency of a liquid surface to shrink into a minimum possible area. So we can say that our surface tension is the tendency of a liquid surface to shrink into a minimum we can say minimum area possible. So if you're talking about shrinking, we mean something contracting, coming like together. So that is how we can define our surface tension. For you to see this surface tension here, there are some mechanisms that are in play. So there are basically two these mechanisms that play around to give us this shrinking or elastic manner of the liquid surface. Let's look at this first one here. So we can say that there is an inward force on the molecules in the liquid. So if it is the force on the molecule of the liquid, let's see how it behaves. So we can say that we have it as our mechanism. Mechanism in play. So our first mechanism is that there is an inward force on the surface molecules. We have our inward on the surface molecules. So this inward force here causes the surface molecules causing them to contract. We are going to see how this is possible, how an inward force on the surface of, on the molecules on the surface of a liquid can cause a liquid to contract. So the second one, we have also another play in this, which is that we have a tangential force. Tangential force that is parallel to the liquid surface. So now, if we know that those are the two mechanisms we have, how do these mechanisms bring about the theory of surface tension? So let's see that. So we are going to see that in the causes. It is because if you combine these two play here, it will give you the surface tension. Now let us see how that is possible. So it can be either, you can call it the causes of surface tension, or you can say the mechanisms in play. You'll see that water has got molecules. Not only water, but every other liquid has got molecules. So these molecules here have forces of attraction and repulsion in them. So you'll find out that these molecules here are due to cohesive forces that brings about their attraction and the repulsive forces. Let us see how this one works. If we have our container, we assume, so this container has got liquid in it. So this liquid has particles which we call as the molecules. There are molecules all over this liquid here, up to the surface of the liquid. So you'll see that these molecules have got forces of attraction in between them. So they attract each other like that in all direction. Even these ones on the surface here attract themselves. Got this? They get attracted to the molecules that are inside the liquid. So if it is like that, we'll see that these molecules that are inside, so like here, if we have it like this, let's take one molecule here, and this is the surface of the liquid. If it is not on the surface, just right there, that means that the forces of attraction that are all over this in all direction will be equals to 0, because all these forces will be equal. That's why it is, when you get them, you will find out that the resultant is 0. So what of the liquid molecule that is right at the surface? Let's look at this. So we have, this is our liquid molecules. So this is the surface of our liquid right there. We say that, let's have this one a bit lower so that we have this right at the surface here. So if you have it like that, what happens? You'll see that these other molecules that are at the surface here, they only have forces of attraction that are taking them downwards inside the liquid, because we say that with cohesive forces, the liquid particles try to pull themselves together. So you'll find out that this one here, this molecule at the surface, will be experiencing inward forces and forces towards the sides to attract themselves onto the next molecule of the liquid. So these inward forces here will cause tension right here on top of on the surface of the liquid, because if you look at this, there are no molecules above that. So this water molecule here will not have any force experiencing there. So we are going to have this at this point here, this is where you see that it is the liquid and air boundary there. So if it is liquid and air, that means that this liquid is already, these air molecules here are not having very strong forces of attraction with the liquid molecules, because of the cohesive behavior of the liquid molecules. So you'll see that because of these inward forces, this tension here causes this surface of the liquid to behave in an elastic manner. So that is how our surface tension comes about. It just comes about because of these forces of attraction and the cohesive behavior of the molecules of liquid. So you see that instead of them attracting themselves with molecules of the air, the adhesive forces between the molecules of the air and the molecule of the liquid is very weak compared to the cohesive forces of in the liquid molecules. So if we know this is how it behaves, so let's look at some effects of this surface tension. So we can have it here as effects of surface tension. If the surface of the liquid behaves in this elastic manner, what other effects can it have? Let's look at one of the effects, which is known as the beading of rainwater on a waxy surface. We are having this one of rainwater on a waxy surface. It is not a must that it should only be the rainwater, but in this case I am taking it as the rainwater because we want to use an example of the leaves. So if you take when it is raining, you look at our leaves. The leaves do not water doesn't always remain on top of the leaf just like that, because these leaves here are a bit waxy. If you look at the surface, it's very smooth. It appears as if they have applied some grease on it, but which is not the case. That is its nature. So you'll find out that when rain drops on the liquid, on the leaves, what happens is that it will try to form some circular kind of thing like this. We have, if this is our leaf, so as the rain drops on it, if it is not a lot, the drop will cause something almost like that, almost circular in nature. What happens is that due to surface tension and because of the cohesive forces in the water molecule, you'll see that it will try to attract itself, and due to surface tension, this drop here will be formed in a circular way. It will appear a bit more spherical like that. From this other shape here, because of surface tension, it will appear as spherical like that. So this is one of the effects of surface tension. You can also try it at home. Just get a leaf, try to put some drops of water on the leaf, and you see what will happen is that this water here will try to form some circular kind of thing. So this is due to the surface tension. So we have another one, which is flotation of objects that are denser than water. We have it as flotation of objects that are denser than water. You see that flotation of objects, liquid is, of course it has the weight, yes, we say it is dense, but then you find out that there are some other objects that are denser than this liquid, denser than water, but still they float on top of the water. Why is that? And how is that possible? That is due to the effects of surface tension. Let's take example of some insects. If you go to a swampy area, or even though there is water just around the hub, if you try to look at it, sometimes you find some insects walking on the water surface. Instead of them sinking, they remain floating on the water surface. Why is that? Let's take example of we look at e.g. Let's take example of an insect known as the water striders. You'll see that they go on top of water and they float. Why? Because when these water striders come on the surface of the liquid, they do not wait. Their feet do not wait, because if you want to see this theory here, it only happens to objects that are non-wettable when you put them on water. So you'll see that the legs of these striders here have got molecules, and at the same time the liquid has got molecules. But then you will find out that these molecules on its legs have a very weak adhesive forces of attraction between them than the cohesive forces of attraction in the liquid. So you'll see that when they try to go on, or when they first come on, when they first come on top of the liquid, sometimes the leg try to go inside, but then it does not penetrate. What happens is that this surface tension will try to recover just the elasticity of the liquid, so that it will take the liquid surface back and flattens the liquid surface instead of it, because when you put the leg, it will try to cause some kind of curve like that in the liquid surface. So this surface tension what it will do is it will not decrease, but it will just try to push the legs of these water striders up so that it can flatten and regain the elasticity of the liquid. So that is how it helps these insects to walk on the water. If this one is very hard to find these insects, you can also try your own experiment at home. What do? You can get a tray or a basin, pour some water in the basin. So when you have this water, get a tissue paper. You first put a tissue paper on the surface of the liquid in the basin. So you get a pin. It can be a safety pin, or you can get a needle. So you try to apply some grease on it to wax it a bit, the needle or the pin. Try to put it on the surface, on top of the tissue paper you had placed on the surface of the liquid, and then observe what will happen. You'll find out that this tissue paper will sink to the bottom of the basin, but then the pin will remain at the surface, even though the pin is much denser than the tissue paper. You'll see that happening. So that is because of the surface tension, the elasticity of the surface of the liquid. So we still have another effect also. You'll find it as separation of oil and water. It is not only oil and water, but we can say immiscible liquids. We can say separation of immiscible liquids. If we're talking about immiscible liquids, what type of liquids are those? We mean liquids that when you try to mix them together, they cannot mix. So they do not form a mixture. One will remain on top of the other. As the other one goes down, they will have an interface. So the example of that we can see you can use water and oil. You see that when you pour water in the oil, they do not mix. You will see the layer of the liquid, the water alone separate, and then the one which is less denser comes on top of the other liquid. So how do we use this surface tension? How does surface tension help there? Because we say that the surface of the liquid is already formed, and that forms an interface. So you find that it is very easy for you to try to separate one of the liquid that is on top from the other one that is lower. So this liquid, this one is sometimes also known as the force that is in between them is known as the tension. We can say it's the tension interface. So with that, let's look at some effects, some factors that affect surface tension. But if you look at the effects of surface tension, they are not just limited to the three we've listed there. So these are not the only effects. There are very many effects out there. Some of them can also be, you can also find some when you're using the tap. As you're opening the tap water, then you close it. What happens is that you will see some liquid drops remaining at the surface on top of the tap in an elastic way. It does not fall. It takes time. When it wants to drop down, it will move down in an elastic way. You see it pulling itself as if it is an elastic object, affecting surface tension. So what could be these factors that can affect the elasticity of the liquid surface? There are basically two, and those are the two we shall be learning about. One is the temperature. We have the temperature. What happens when you increase the temperature of the liquid? So you'll see that surface tension reduces with an increase in temperature, meaning that the moment you increase the temperature, that means the elasticity of the liquid surface is being reduced. So this one happens that because you see that at the boiling point, when it reaches boiling point, our surface tension is equivalent to 0. So as you continue boiling this liquid, it will reach some other level of the temperature known as the critical temperature. So when it reaches this level, critical temperature here, you'll find out that the liquid tends to behave like the gas. Why? Because this liquid will start to change into water vapor. So when it is turning into, the steam is more like the gas. So at critical temperature, the surface tension there vanishes, of the liquid vanishes, because there the molecules of the liquid behaves as similar as those of the gas molecules. So the moment you just try to increase the temperature of the liquid and you put an object on top of it, it will not remain on top there because the elasticity has been broken. It will sink instead. So the other factor we have there is impurities. So what happens when you add these impurities into liquid? So these impurities here tend to reduce also surface tension, but it depends on the level of contamination of this impurity. The impurities we are talking about can be, you can have powdered soap, or you can have salt. Salt is also an impurity. So you'll see that when it is very soluble, when the solubility level is really high, like sodium chloride, which is our common salt, what happens is that instead of it reducing this, it will instead of it reducing the surface tension, it will increase it because the level of contamination there is a bit lower compared to other impurities like we can talk about the powdered soap. So when you pour this powdered soap in liquid, what happens is that the molecules of the liquid will have, let us assume this is our liquid in the benzyl. So we are pouring this powdered soap in the liquid. So you'll see that this one here will tend to come and circle up the water molecules. So as it is trying that, the molecules, it will break the intermolecular forces, the cohesive forces that are in between the liquid molecules. So as it breaks that, that means that it's going to reduce the inward force that was creating this tension right at the surface of the liquid. So you'll see that when this force is broken, that means that the elasticity level here is also reduced, meaning that our impurities, whenever you add impurity in the liquid, it will reduce the surface tension. But as I said, it depends on the level of contamination. How will this impurity contaminate the water? So for today we've learned a lot. We've talked about surface tension. I hope you can now define surface tension. We talked about the effects of surface tension, and these are not the only ones. We are not limiting you to only the three. There are so many other effects you can find. So we have seen that the factors affecting surface tension, these two here, are the major factors that affect this surface tension. So with this, we've come to the end of our lesson for today. We shall meet again in the next lesson.